Hi, I'm Ashish. I'm a data engineer at dltHub, and here I'm going to be demonstrating the dltHub Workspace workflow. It's a workflow designed to help developers build, run, and deploy their data pipelines in a manner that requires less time, a lower level of effort, and in general, provide a more frictionless experience. This workflow comprises 5 steps, but in this demo, I'll mainly be focusing on the first 3. So let's go over them very quickly. First, of course, is loading the data. The dltHub Workspace provides thousands of LLM scaffolds that contain templates that you can use to ingest data from the REST API source of your choice. And they're designed to work with AI integrated IDEs, such as Cursor and Continue. Once you've ingested your data, you of course want to ensure the quality using some form of data validation. In this workflow, you can do this with the DLT Dashboard, the DLT MCP server, or the DLT CLI, or a combination of the 3. And once you've completed your data validation, you can then start investigating your data and extracting insights by performing transformations and creating reports. In this workflow, we do this with the combination of Marimo notebooks and the Ibis library. Marimo notebooks are reactive, and they're also essentially just Python code, so they're very easy to version and share. On the other hand, the Ibis library basically provides an abstraction layer over your databases. So what that means is, from the user's perspective, all you have to do is write your queries, and Ibis will handle the query translation and the execution, as you'll see in a moment. I'm going to now demonstrate the first 3 steps in this workflow by performing a quick case study. In this case study, I'm going to be collecting data off our own DLT repository using the GitHub API, and I'm going to answer a very simple question. How many commits are being made in this repository? I'm going to be specifically checking how many commits are being made per month and how many commits are being made by each contributor. So let's get started. Here we have the workspace page in the dltHub website. If I scroll down a bit, I can see all the scaffolds that are currently available for building DLT pipelines. In our case, we want to build a pipeline that uses the GitHub API source. So in the search bar, I'm just going to click GitHub and I'll select GitHub. And when you click on one of these scaffolds, you'll be provided a template and a set of instructions for building and running a pipeline for a given source. So if I scroll down, I can see those instructions here. And for our demo, I'm basically just going to be following the steps listed in this scaffold. So here we have a completely empty project in the Cursor IDE. This is where I'm going to be following the steps provided in the GitHub scaffold, where I'm going to build and run the pipeline and also, perform the data validation and build our report. So the first thing I'm going to do is I'm going to create a virtual environment. So I'm going to use UV for this. And I'm going to enter set environment. Oops, there we go. And now I'm going to be performing our installations, which in our case is just pip install DLT Workspace. And that's going to be the only installation we need to make. So with the workspace installed, we can create our DLT project. And if you're familiar with DLT, it's usually done in the form of a DLT init command. When you're using the workspace, there is a slight variation. So following DLT init, we have dltHub. And then following dltHub, you write down the source of interest, which in our case is GitHub. And then you end this with the destination of interest. So in this case, that will be DuckDB. So I'm going to enter, and it's going to create our project for us. Okay, so everything was successfully run. If you look on the left now, you'll see that a lot of files have been created. From the user's perspective, we only ran one single command in the CLI. But as you can see, a lot took place just now behind the curtain. So I want to take some time to really go into detail and talk about what some of these files are, because they're going to play a role in these subsequent steps. So first, of course, we have our Python script. So this is the script that's going to be facilitating our pipeline run. And just a quick glance, you can see we're importing some libraries. We are defining our source. If you're not familiar with DLT, we use a config-driven approach to define our source. So what that basically means is you just have to give simple pieces of information like the base URL and other resources, and DLT will take care of the rest. Logic like pagination, retries, rate limits are all built in. Once we create the source, we create our pipeline object, and then in this line here, we facilitate the pipeline run. So if you take a look, though, specifically at the source configuration and the pipeline configuration, you'll notice that we're using a lot of placeholder values. So as is, this script is just a blank canvas, and we're not going to be running anything with this script alone. Now, as a user, one option you have is to manually populate this config with the relevant pieces of information. You can replace the base URL, the resources. You can do the same with your pipeline. But of course, that can be time consuming. And in addition to that, some REST APIs are notoriously difficult to work with, right? They have maybe messy or poorly written documentation, if they have documentation at all. So why not just have LLMs do the work for us? And by that, I mean, why not write a prompt and have our LLMs populate the configuration for the source and the pipeline for us? That sounds good, but that's not exactly a new and novel concept. People have been relying on LLMs for code generation for a long time now. However, those same people will most likely report high rates of erroneous code, a lot of hallucination that just leads to a lot of trouble in the long run. Thankfully, in this workflow, and thanks to this init command that we just ran, we have additional files that'll help us mitigate those issues. So first, we have the cursor rules, as you can see here. So these rules are basically supplementary sets of instructions that you provide to the LLM to make sure that they build your DLT pipeline properly. And even if that pipeline returns an error, with these rules, your LLM agent will be well equipped to debug and troubleshoot in little time. So on paper, it just looks like 4 files, but these 4 files are the product of countless hours of experimentation and testing, just a lot of trial and error. But these 4 files are, as a result, very generalizable. These files you get for any REST API source, and they'll be able to help your LLM agent perform adequately. Something that is not provided for every single source, and something that is, in our case, unique to this GitHub scaffold, is this YAML file that you see right here, this GitHub docs YAML. And what this basically provides is all the information that the LLM needs regarding the GitHub source. And the really cool thing about this file is that we can build our pipeline without even looking at our GitHub documentation, because all the information is already provided in here, and it is provided in a very LLM readable format. So as a user, you can simply create your project and then with a prompt, populate the configuration, and you don't even have to look at any documentation. So I think that's pretty cool. Next step, of course, is once we have built our project, we now can write our prompt and build the pipeline that we want. So I'm going to, for now, put away the terminal, and I'm going to open up a chat. And if you look here, you can see that the rules are already being applied by default. So whatever I type in here is going to be supplemented by these rules. Now, the GitHub scaffold that I showed you previously already provides a sample prompt. So I'm just going to be copying that in for a start. Now, of course, only you know what you want. So although this prompt is a good place to start, we have to tweak some things and add some things to match our use case. So in our case, I need to use the right endpoints. So I am collecting data on commits. So I, of course, want to get the data from the commits endpoint. And I also want to break down those commits by contributors. So I also want the contributors endpoint. And a final detail is I'm going to be providing the repo because the pipeline should know which repo to collect the data from. So I'm going to say owner is dltHub, and repo is DLT. So once I submit this prompt and the rules, the agent is going to modify this canvas and it's going to yield a pipeline script that should work well, but we'll see. I'm going to submit. So let's take a look at the changes made to our script. As you can see, all of the placeholders are now being replaced with the configuration that is specific to our use case. So I'm just going to accept all of these. Actually, let me just keep all. And let me follow their instructions, which is first to get the GitHub access token. Okay, so I'm just going to paste that here. And there we go. Okay, so we've provided our credentials in the secrets.toml. Now we can finally run our pipeline. And let's see what happens. UV run python GitHub pipeline. Okay, and as you can see, we are getting an error message. Just to break this down, our LLM agents are inherently non-deterministic. So even with the right amount of context through our cursor rules and our GitHub docs YAML file, there's still a possibility of errors being made. Now, you could, as a user, manually inspect the error, find the source, and then make the fix. But let's think about it. We already have an LLM armed with all the knowledge it needs to run and debug DLT pipelines. So an alternative to manually debugging is literally just to take this error message and provide it to the agent and have them make the fix instead. So let me do that right now. So I'm going to paste it here and let's see what our agent has to say. Okay, so after giving it the error, it claims to have found the issue, and the issue seems to be in the pagination configuration. So if I were to scroll up at what they show, they're basically saying that this one line here should be removed. Now, let me accept those changes. And now, as instructed, I'm going to just run the pipeline once more. And let's see what happens now. Okay, and as you can see, our pipeline is running without issue. So if you're unfamiliar with the logs of a DLT pipeline run, I can just quickly explain it. So a pipeline run comprises 3 steps: extraction, normalization, and load. So on the top, you can see what phase we're in. So in our case, we're in the extraction phase. And in the bottom for each of these records, you can see the endpoints for which we're collecting this data. And next to these endpoints, you can see the corresponding number of data items. You'll notice that although the number of commits is going up, the number of contributors remains at 131. That is most likely because we have no more than 131 contributors. Now, if you're wondering as to why the LLM agent was able to correctly identify the issue, well, it's because, as it said, the issue was clearly a pagination issue. And we actually have one page in our cursor rules that is solely dedicated to teaching the LLM agent on pagination. So it was already well armed and well equipped with the information needed to resolve this issue. So with this workflow, as you can see, we're able to build and run a pipeline successfully without having to write a single line of Python code, which is really cool. And even though these LLM agents have the capacity to make errors and write erroneous code, in this workflow, we're making sure that we always provide it with sufficient context before submitting any prompts. So even if there are any issues, those issues will be small and they'll be easy to rectify. So I'm going to wait for this pipeline to finish running before we move on to the next step. So as you can see in the terminal message, our pipeline ran without issue, but as a user, you still want to ensure data quality. That brings us to step 2, where we validate our data. So I'm going to close our chat, and inside terminal itself, I can open up our dashboard web app by just saying DLT pipeline. And then the name of our pipeline, which if I scroll down, is GitHub pipeline and show. And if I press enter, it's going to send me to the dashboard in the browser. So as you can see, we have our DLT dashboard opened up. Currently, it's in some port in localhost. And this dashboard gives us a lot of information on our pipeline and the data that it had loaded. So at the very top, you can see an overview of the pipeline, just key pieces of information like the destination, the date of last execution, and so on. If you want, you can also inspect the schema of the data that has been loaded. So you can of course see the schemas for the data for the endpoints that were collected. If you want, you can also inspect the child tables that were created, because behind the curtain, DLT does transform a lot of nested JSON responses and store them in child tables. So this is a place where you can inspect those tables yourself. And if you want, you can also inspect the metadata that has been created by the DLT pipeline runs. So in addition to schema inspection, you can also browse your data itself. As an example, here we're allowed to write simple SQL queries and just preview our data. Here's an example of what the commits table looks like. We can also inspect our pipeline state. As you can see here, we can inspect our last run trace, just giving you a good look at what that looks like. And we can inspect our pipeline loads. In our case, we just ran the pipeline once, so there's only going to be one row. And finally, and this is a good segue to the next step in the workflow, we can connect to the Ibis backend for this pipeline, and that'll make this destination visible when we open up our Marimo notebook. Okay, so once we finished all of our data validation to ensure data quality, we move on to step 3, which is to perform our transformations and to build our reports. So like I said before, this is done with the combination of Marimo and the Ibis library. So to use both of those, we of course need to install them. So I'll do that with a quick pip install, and I'll say Marimo and Ibis. I'll also include a library called Altair, which is a visualization library. It's very compatible with Marimo. Once I've installed everything, I can create my Marimo notebook, and you do this with the Marimo edit command in the CLI, and you follow this with the name of your Marimo notebook. I'm just going to call mine my notebook, and I'm going to end this with the py extension because this is a Python file. And this will edit the file if it exists, and if it doesn't, it'll create it for you. So once I hit enter, it's going to open up my notebook. Here we have our Marimo notebook. And if you're familiar with Python notebooks like the Jupyter notebook, then this is going to look pretty familiar to you. You have kernels, and then you have their respective outputs. So the first thing I want to do is just to do all my imports. And I'm going to run this. Okay, once we do that, I want to establish a connection to our DuckDB database. So if you look to the left in the data sources, you can see that no tables are found. I want to establish our connections so that we'll be able to see all of the data that we have. So to do that, firstly, I'm going to access our pipeline with the DLT library. So I'm going to create a variable called pipeline, and I'm going to use the attach command here. And in the attach command, I want to provide all the important parameters regarding my pipeline, including the pipeline name, the dataset name, and the destination type. So let me just do that very quickly. So I've provided all of the configuration here. And if this part looks familiar, it's because this is the exact same configuration that we or the LLM agent provided when building our pipeline object. So once we have all this information and we have access to our DLT pipeline, we now need to establish a connection to our database. This is done with the Ibis library. So I'm going to create a variable called con, and I'm just going to say pipeline.dataset.ibis. dltHub.ibis. And I'm going to run this kernel. And once I run this kernel, you can look to the left now, and you can see that all of a sudden we can see our DuckDB database. We can see our GitHub pipeline, and we can see the data within, our commits, our contributors, as well as our metadata. A really cool thing about this approach here is that we can access different databases and different destinations by just tweaking the configuration here. So for example, in our case, we have the GitHub pipeline that we're accessing in a DuckDB database. But if we were to store a pipeline in, let's say, Snowflake or BigQuery, then all we would have to do is simply, tweak the destination, and then all of the remaining logic can stay the same. I think that's pretty cool. We can start working on our transformations and our visualizations. The first thing I want to showcase in the Marimo notebook is the freedom that it provides you with regards to how you want to interact with your database. If you prefer writing in SQL, you can write in SQL. If you like to write in Python, you can write in Python. So basically, you can play to your strengths. So the first thing I'm going to do is I'm going to showcase this by doing a simple query where I'm going to count the number of missing values in each of these two tables, commits and contributors. So for contributors, I'm going to create another cell. And if you look on the bottom, you can see that there's an option for viewing as SQL. And when you click this, you have the option of basically writing your SQL queries directly. So you don't have to worry about any annoying syntax. You can just directly write your SQL queries, and the IBIS library will handle the rest for you. Very quickly, I want to have the right database connection. And now I'm going to write my SQL query. Okay, so I have my SQL query. It's just a simple case when, where I count the number of missing records for each of these variables, login, ID, and contributions. And when I press enter, you can see that we have a neat little output here with our results. So I'm going to do the exact same thing with the missing values and commits, but this time I'm going to use Python. So I'm going to press enter and run it. And as you can see, we're able to see all of the missing values for each of these rows. That's just a quick showcase of how you can write both SQL and Python in the Marimo notebook. I'm also going to showcase its capacity for data visualizations. So I'm going to now answer the two questions that I had asked, and that is how many commits we have in this DLT repository, 1 by month and 2 by contributor. Here, I'm using Python to compute the commits per month, and I'm storing it in this variable here. And then using Altair, I'm building a line chart. So if I run the script here, you can see a neat and nifty line chart here. And if you were to hover, you can see that it's interactive, which is just one of the traits of Altair. And I'm going to do the exact same thing for computing the commits by contributor. I'm going to compute the value, store it in a variable, and then use this variable to create a bar chart with Altair. So I'm going to run this. And there we go. Much like the line chart, you see an interactive bar chart that gives us a lot of insights into who's been contributing the most to this DLT repository. So with that, we've concluded step 3 of our workflow. I hope through this demo, you were able to see why the dltHub Workspace workflow is so powerful. With just a few CLI commands and no lines of Python code written, we were able to build and run our DLT pipeline. Following, we were able to easily interact with our pipeline and its data for data validation and report generation with the DLT Dashboard and the Marimo Notebook environment. If you are curious as to what the remaining steps in this workflow are, I can go over them very quickly. So after we are able to get everything running locally, of course, the next step is to deploy and share. And once we've deployed and shared, the next step, of course, would be to automate and maintain our pipelines in production. Of course, that is outside of the scope of the demo. If you are interested in these steps, then please stay tuned. We'll be releasing more content in the future. But that marks the end of this video. Thank you for watching.